Hi, welcome to SD-Access Design and Deployment video series. My name is Karthik Thumla. I'm the Technical Marketing Engineer from Cisco's Indian-based networking group. In this particular video, I'm going to talk about Cisco SD-Access wireless updates and the Fabric in a Box deployment options, part of the latest 2.1.2.5 DNA Center release. So with that, let me show you the agenda for this particular session. So we're going to cover the fabric-enabled wireless with the N+1 HA and the rolling AP upgrade. This is one of the new functionality we have introduced with 2.1.2.5. And along with that, we started supporting IPv6 on Fabric WLCs, mainly the iOS XE-based wireless LAN controllers. Earlier, it was only supported on AeroS. And we'll also cover the FlexConnect over-the-top support in Fabric. So today we support over the top, we support Fabric enabled wireless, but we don't support FlexConnect, but that is something which we have introduced with 2.1.2.5 release. And finally, we'll close with Fabric in a Box deployment models. So the Fabric enabled wireless, when you're running N+1 HA, along with that, how we are going to do rolling AP upgrade. So this is something which has been working within DNA Center since 1.3, but when you deploy Fabric, then that is something we started supporting with 2.1.2.5 release. So part of N+1 architecture, primarily, if you take a look, we have two different kinds of high availability. One is the SSO mode and the other one is N+1 HA mode. So when you're running N+1 HA mode, primarily you'll be having two wireless LAN controllers. One is the primary WLC and the other one is secondary WLC. So those two WLCs are independent to each other. That means unlike SSO, they don't share any configuration, which includes like IP addressing, this sharing of the configuration, whatnot. So these two are independent to each other, and your APs will go and connect via CAFAP to the primary WLC. And once the primary WLC fails, it will all go back and connect to your secondary WLC. And N+1 HA is available pretty much on all the wireless LAN controllers, including the embedded wireless LAN controller, which is the WLC feature support on the Catalyst 9000 switches. So some of the design considerations when you're running N+1 HA primarily is one, so each WLC has to be separately managed by Cisco DNA Center. Like if you remember in the earlier SSO mode, we can go and you can set up SSO where the two wireless LAN controllers will act as a single WLC, but here each individual WLC has to be managed separately by Cisco DNA Center. And when you are managing the WLC, the APs which are part of that particular site has to be mapped to a primary WLC as well as a secondary WLC. So you need to add a location where this primary WLC acts. And similarly, when you look into the latency, the both primary and the backup WLC round trip time should not exceed 20 milliseconds. And along with that, when you're implementing rolling AP upgrade option, when you're running N+1 HA, so that is something which can be done on the Catalyst 9000 hardware appliance as well as the virtual machines, which is 9800 LCDs. But if at all you are trying to do it on AeroS or embedded wireless LAN controller, which is running on Catalyst 9000 switches, that is something which we don't support. So these are some of the design considerations when you are configuring N+1 HA. And let's look into some of the key differentiations between N+1 HA versus SSO mode as far as Fabric is concerned. So the first thing, when you're running Fabric, so when you're running N+1 HA, as I mentioned earlier, both the wireless LAN controller would remain independent to each other. So that means Cisco DNA Center sees them as two independent WLCs. But when you're enabling SSO mode, the wireless LAN controllers will be seen as a single entity. And for this, we need to map them to a different location. That means it could be based on a site location, building, or a floor, but we need to map this wireless LAN controller to both primary and the secondary location. And here, when you're running N+1 HA, both the wireless LAN controllers will communicate with the control plane node because they are independent to each other. Whereas with SSO mode, the WLC communicates with the control plane node because it's a single entity. And both the Warsan controllers, if in case the primary WLC fails, the APs will be reinitiated and connect back to the secondary WLC. So whereas with respect to SSO mode, when the active WLC, if in case fails, then automatically, since it is running as an SSO, the new active will come back, and that will actually do a bulk update to the control plane node regarding all the wireless controller clients, which are or the wireless hosts which are connecting to the fabric. And with respect to N+1 HA, the APs and the clients typically go to the secondary WLC if in case the primary fails. Whereas with respect to the SSO mode, since this is a single entity, it's automatically the new active Warsan controller will take the precedence, and that will come back and it will connect to your fabric wireless host. So here is some of the workflows with N+1 HA. As you can see, first we need to go into your Warsan controller configuration part of your provisioning workflow, and there you need to add the main active WLC, which would be part of this primary location. So as you can see here, I have two Warsan controllers, which is 9800CL1 and 9800CL2. So I'm going to map them where the 9800CL1 will be managing a primary location. And here also I have an option to enable rolling AP upgrade percentage as well. And then I'm mapping the primary location for that particular WLC. And then I have an option whether I want to enable N+1 HA with rolling AP upgrade and the percentage of number of access points, which would be pointing for this particular upgrade. So I can enable the checkbox saying like 25%, 30%. And then I have an option to configure the mobility group for that for N+1 HA configuration. So once you give it a name for N+1 HA mobility group, and once you add it, automatically the secondary Warsan controller will be shown as your mobility pair. And once you provision that secondary Warsan controller, automatically the N+1 HA configuration for secondary Warsan controller location will be shown. So here you can map the secondary location for your secondary Warsan controller, and you need to map the AP managed location for this. So here I need to point this as like earlier, if you guys have seen, we have selected floor 1 for the primary AP location, and for the backup we have selected floor 2, but in this particular secondary Warsan controller I have selected floor 2 as a primary AP managed location and floor 1 as a backup AP managed location. And here is where you see the summary of all the mobility group configuration which we have provisioned part of N+1 HA, and along with that you would also see the rolling AP upgrade configuration which we have configured part of the provisioning workflow. And once you save it, automatically this configuration gets provisioned on both the Warsan controllers, and this is just can be configured within few clicks of a button and pretty straightforward. So with that, let me move on to the next topic, which is IPv6 support for fabric Warsan controllers. So this is something which we have started supporting with 1.3, where we started supporting dual stack configuration, part of your overlay subnets, where IPv6 is supported on your AOS Warsan controllers. But with this particular release of 2.1.2.5, we started supporting IPv6 on the Catalyst 9800 series Warsan controllers, as well as the embedded Warsan controllers, which are running on Catalyst 9000 switches, like all the 9800s, 9840s, as well as the 9800 CL and the L series, along with the embedded Warsan controllers, which we started supporting on 9300s, 9400s, and 9500s. All these support IPv6 configuration. And some of the key design considerations when you are running IPv6 is, first, we need to run at least 17.3.1 or higher. So we started supporting this IPv6 on iOS XE when you're running 17.3 or higher. And then the SLAC support for this is only on /64 address pool or higher. So when you're running IPv6, we have the subnet, anything above /64 subnet, we support SLAC addressing. And as far as multicast is supported, like in general, when you're running IPv6 multicast, mainly with fabric-enabled wireless or embedded Warsan controllers or 9800 CDs, we support only hidden replication. So that means we don't support any native multicast configuration, which includes underlay. So only hidden replication is the only IPv6 multicast support feature today. And with respect to IP address pools, so today we support dual stack. That means like if you already have an IPv4 address pool configured, I can go and I can modify it and I can add IPv6 capability to that. But if you want to downgrade any IPv4 and IPv6 dual stack IP address pool, that cannot be possible. And also, since ICE doesn't support URL redirect for IPv6, so we don't support any GIST workflows with IPv6 traffic. So, and also with respect to the AP, today we don't support dual stack IP pool with InfraVN because today APs in general, because we have external nodes and APs which are part of InfraVN, we don't support any dual stack configuration on those as well. So moving on to the next topic, which is the FlexConnect over-the-top support in the fabric. So we support today mainly mixed mode, which includes fabric-enabled wireless as well as over-the-top. And we can also run combination of both fabric-enabled wireless and over-the-top. But what we don't support is FlexConnect over-the-top wireless. So that is something we started supporting with the latest 2.1.2.5 release. So when you're running FlexConnect, like very similar behavior with respect to traditional wireless LAN controller, where we do the local switching of your data traffic at your AP. So that means in this particular fabric deployment, I can run a FlexConnect wireless LAN controller, which can be connected to your main fabric site, and I can run a branch site where I can only connect an AP to a fabric edge device. I can still stitch my traffic locally using the FlexConnect, and I can connect to my wireless LAN controller for the CAPFAB traffic. And if at all I want to do any policy-based enforcement, I can still leverage the traditional TrustSec-based policy enforcement on access points by leveraging the AP-based enforcement. And today, FlexConnect over-the-top wireless is supported on all the wireless LAN controllers, pretty much like 3500s, the 8500s, and the 9840 iOS XE based platforms, as well as the 9800 CL series. So with respect to the policy enforcement, as I mentioned, like traditional TrustSec behaviors would still apply here. So when you're running any wireless host configuration, which includes IPv6 as well as any IPv4 in general, right? So all that, as far as the policy enforcement is concerned, if you're doing wireless to wireless, the enforcement happens at the access point. And if you're running from wired to wireless, so typically the border node where you would be leveraging SXP and we would be pushing that SXP binding information, you would be doing the policy enforcement. And again, this particular configuration is not automated. So you have to either use CLI templates to push this configuration, or you need to manually write it using the CLI on the boxes. And here are some of the roaming requirements for the clients and applications which are running FlexConnect over the top. As you guys can see here, if you're running SD-Access wireless in general, and if the APs are connected to the same fabric edge device, so the roaming latency is around like 70 milliseconds. And when you have like two different fabric edge devices, it is like close to like 85 milliseconds. But when you're running FlexConnect over the top, it is greater than like 700 milliseconds. So there's a lot of difference with respect to the embedded wireless LAN controllers with FlexConnect over the top versus this classic SD-Access wireless. So please take this into consideration whenever you are designing any of the FlexConnect over the top wireless deployments as far as fabric is concerned. So it's mainly it would be sensitive to some of your latency sensitive applications such as voice over IP. So here is the configuration which needs to be enabled on the fabric edge device. And as again, like since this FlexConnect over the top cannot be automated today, we just use CLI templates configurations. So as you guys can see on the left, I can enable using interface templates. where I can input the interface template part of my DNA Center workflow as a variable. And also I need to configure the native VLAN configuration. So either I can use an interface template using variables, or I can directly go to the box and configure the CLI configs for that. And the only key thing here is we need to configure the native VLAN. And along with that, if at all you want to configure any of the SGD related info, like the policy propagation, then automatically we need to enable inline tagging configuration. So again, all this has to be either run using CLI templates or manually written through CLIs. So let's look into the DNA Center workflow for this. So the first thing what you need is, like, you go into the DNA Center under network settings for wireless, you would need to configure the SSID for your FlexConnect over the top. And part of it, it will ask you whether this is a FlexConnect over the top wireless local switching SSID, and you can select yes. And it will ask you for the local VLAN for that particular SSID, and you can point that particular local VLAN. And part of it, you will be assigning the same VLAN on your wireless profile when you select your clients to push the configuration. And also you will be provisioning your wireless controller with the same local switching VLAN which you have configured in the DNA Center UI. And once you have configured that, you need to go into your inventory. Inside the inventory, you would be seeing your wireless controller. And when you provision it, it will ask you for the configuration, if at all you have anything for your mobility group and things. Once you select all that, finally in the summary, as you guys can see, we have a FlexConnect option enabled part of the workflow. And this particular configuration is being provisioned on the Cisco DNA Center. And again, on the Fabric Edge device, the trunk configuration can be done typically using interface templates, as I shown earlier, or you can manually go into the box and write using the CLIs. So with that, let me move on to the last topic, which is the Fabric in a Box deployment models. So we started supporting the embedded wireless LAN controller typically on the 9K switches, starting with 1.2.10 release, so which runs iOS XE with 16.10. So part of it, we started supporting it on 9Ks, where we could run like a border control as well as the embedded wireless LAN controller functionality on the 9K boxes. So in the first use case, as you guys can see, I have connected an extended node to a Fabric Edge device, which in turn is connected to a border and control running an embedded wireless LAN controller. And similarly, with 1.2.10, we also supported the extended node connecting to the Fabric in a box, which also runs embedded wireless LAN controller as well as Edge. And also we supported extended node connecting to the Edge, which is running the embedded wireless LAN controller. So I have like a border and control hanging off on the top, connected to my Edge and my wireless LAN controller, which in turn is connected to my extended node. And today I can connect my APs to my external node. So we can still enable Fabric enabled wireless while connecting my APs to the external node. So we started supporting this functionality of running embedded wireless LAN controller on Edge from 1.3.1. And the next deployment model, you can see we can connect the external nodes directly to the Fabric in a box, where the external node is directly connected to the FIAB, which in turn connects to an AP. So we started supporting with iOS XE 17.1 and 16.12 with DNA Center 1.3.3. And similarly, in the same example, we can connect an external node directly to the FIAB, which in turn is connected to an Edge. The Edge is in turn connected to a FIAB. So that means I can have a FIAB box connecting to the Edge as well as to my external node, where my Edge in turn can connect to an external node. So we started supporting this with 1.3.3. And similarly, I can connect two Edge devices cross-connected to the Fabric in a box, which in turn is connected to the external node. So all these three scenarios are supported, where I can run like all four functionality on the same box. And with the latest 1.3.3, we also started supporting the daisy chaining of the Fabric enabled wireless, which contains all the border edge control and Wireshark controller functionality. Along with that, we have a daisy chaining of edge devices as well as the external nodes connected to those edge devices. So these are the two options what we supported with 133. And with 2.1.2.5, we supported SVL. So SVL is one of the new functionality where we can support on both 9400s, 9500s, as well as 9600s. So here are some of the scale numbers for embedded Wireshark controller capabilities. So when you're running a embedded wireless on a Cat9K switch, so the maximum number of access points we support is 200 and the maximum number of clients are 400. And similarly, when you're running two embedded wireless LAN controllers, then the max access points are double the size. So it is like 400 and the clients are 800. And again, like for any additional scale capabilities, we highly encourage you guys to go and look into our SD-Access scale document, which is available in FlexConnect, as well as for any of the support capabilities, we highly encourage you guys to go and look into the SD-Access compatibility matrix. So with that, let me show a small demo which covers the FlexConnect over the top configuration, which I have shown earlier, part of the DNA Center workflow. So in this particular topology, so I have my Fabric Edge device, which is a 9300 switch, which is connected to my FlexConnect AP, and my Wireshark controller is sitting outside of the Fabric in the data center. So that's the FlexConnect WLC, and which is in turn is connected over my WAN network, where I have a branch where my other FlexConnect AP is connected. So I can show you the configuration which is needed to enable the FlexConnect over the top, as well as I'll also show you the configuration where my endpoint is able to get an IP address, though we are running Fabric in between for this particular use case. So let me go to my remote desktop session, so where I'll be sharing the configuration. So let me go to first Cisco DNA Center. So once you log into the DNA Center, so under design and network settings, you would be going to wireless. So under wireless, as you guys can see, I have enabled this Flex SDA SSID. So let's look into the Flex SSID. So as you guys can see, so this is the Flex SSID, which I have enabled. So here is the checkbox which asks you for the profile. So this is where you need to enable the profile. So as you guys can see, I have my FlexConnect local switching, which is a VLAN which I have configured on the DNA Center. So this is the 1030 VLAN, and I'll show you the configuration part of the workflow in the host onboarding page as well. And I have added two sites. So as you guys can see, my SJC floor site, which is part of the San Jose, is part of this FlexConnect over the top configuration. So once you select this and once you finish this configuration, so the next step is you need to go and you need to provision your Fabric Edge device with this configuration. So before doing that, I just want to quickly show you the provisioning workflow where you go into the inventory of, and you can select a Wireshark controller. So when I do provision the Wireshark controller, so part of the summary config, so you can see the SSID configuration which gets provisioned. So this is all the config which gets provisioned onto that Wireshark controller which is connecting, which is doing FlexConnect over the top. As you guys can see, this contains all the FlexConnect options. So it's FlexConnect enabled as, and my access point which is connected to this particular Wireshark controller should have the FlexConnect enabled. So let me log into my Wireshark controller and let me go to the AP. As you guys can see, this is the AP, which is 2800, and this is running FlexConnect mode. So the AP mode is FlexConnect. And then let me log into the switch, which is a Fabric Edge device. And let me show you the configuration which we have added to enable this AP to connect to the Fabric Edge device. So before going to that, let me go to the campus host onboarding. and the port assignment. And this is the fabric edge device where my access point is connected to. So that is connected to gig 1/0/24. So this is a trunk configuration, as you guys can see. So I can log into this particular box. If I do show run interface gig 1/0/24. So this is the switchboard trunk native VLAN. And again, this is being provisioned via CLI, or you can use any templates using DNA Center provisioning workflow, and you can push it part of the templates. And this is the switchboard mode trunk configuration, which is being added. So this again, it needs to be either done through CLI or using the interface templates. So once you have added all this, and once you profile your wireless LAN controller, as well as your access point, which gets provisioned. So let's connect a client and see if they can connect to that particular FlexConnect SSID and get an IP address. So let me go to my client. So this is my client. So this is my client, wireless client, which is connected to that FlexConnect SSID. We should see a broadcast of Flex SSID here in a sec. And you can see it's a Flex_SDA. It is connected. So let's look into the IP address. So it got an IP address of 172.16.102.201. That is part of our subnet, which is part of the Flex over the top. So let's go back to ICE and verify the authentication of that particular user. So let me do a refresh. So he's an employee 5 user, and he got an SGT of employee. I'm actually pushing SGT here, and this is an endpoint ID. And this is doing PEEP MS v2. And similarly, let's log into the wireless LAN controller. And if I go to the monitor clients and click on it, so as you guys can see, this is connected to the Flex SDA wireless LAN profile, and this connected to the Flex SDA SSID. And here is the IP address and the SGD assignment for that particular user. Yeah, it got an SGD tag of 4. So now if at all I want to do any policy enforcement, I can just use my native trustsec configuration by enforcing the policy directly on the wireless LAN, directly on the Cisco access point, which is 2800 in this particular example. So that pretty much concludes the demo and the session for this particular topic. So with that, thank you everyone for watching this particular session. See you on the next session. Thank you.